Okay, it's fucking hot. Ugh. My sister fell up the stairs and had to get stitches. So, I had to respond to a text real quick. And, oh, chair's cold. I had kickball tonight. 2 home runs, because I'm okay at kickball, actually. Not the throwing or catching part, but the kicking part's okay. And got back late because of it, so less time than I want to program tonight. Of course, the glasses are fucking smudged, but I'm gonna try and focus my brain on this object-oriented programming. So instead of procedural programming, where we're using regular-ass objects and functions separately to do things, so I have some things that store information, and I use functions to, and I use operations and functions to operate on that information and do specific things. Well, everything is kind of itemized and distinct in procedural programming. There's no class. There's no thing that inherently ties player 1 card 1 to player 1 card 2. There's no hand that puts those 5 cards or 7 cards together. Nothing like that. So, we need something to preserve the attributes of real world things. For example, if I'm trying to represent a real world object or thing or person, and I want to represent it in code, and I want to do things to it, and have it behave in certain ways and exhibit certain properties that potentially affect its behavior and the behavior of other things in the environment and universe, it makes sense to create some sort of replica, some sort of copy of that object in code. That means that we need to make something where the 5 cards in the hand are not distinct, or not completely detached from each other. Instead, we create some sort of binding structure that they're all tied to. That way I can reference the one object that owns them, or that they're a part of, maybe children of or owned by as members of, to reference them. Instead, I create a structure, a class called hand, or player card hand, something like that. And inside a player card hand, you have 5 cards, let's say. Now I can use player card hand to access its 1, 2, 3, 4, 5 cards, instead of having these fully detached variables that aren't related to one another. There's nothing that, if I call a function and I want to shuffle the hand, like reorganize your hand, maybe your hand is upside down and you don't know what's in it, and maybe you can fuck with other people by having the cards flip over and telling them to shuffle their hand. And maybe occasionally you can look at your cards, so at some point, oh, I know what this card is, but I don't know what these other 4 cards are. But then you can maybe shuffle them around. Well, I would have to pass all those individual 5 cards to a shuffle function and then move them around. Or maybe maybe we're just swapping. Well, if we're shuffling, and we're doing stuff to all 5 cards, I need to pass all 5 cards to that function. Or maybe I'm flipping them, so maybe the middle and the third and the 5th card are swapped. It would be cooler, though, if I could just take some governing thing and pass that one thing. Boom. This is where classes and object-oriented programming comes in, where we have a different kind of object, a class object. And a class object is this binding structure that holds data members and functions, apparently member functions, I think, together. Their properties. So we can have an object, some thing that has properties that describe it, its diameter, its mass, its attack damage, its health, its speed, its aggression level, its aggro meter, all these kind of things. And we can have things that we do to it. So we could have attack 1 and attack 2 and attack 3, and they play animations, and in those animations, in the game engine, however that works, whenever there's a collision between things, the damage is applied and whatnot. So we can have behaviors of this class object and properties, and they can be integrated so that we can include functions and definitions of types like enums, like a Pokemon, for example. We have a class called Pokemon, a struct called Pokemon, and we create an enum inside it for the different types they could possibly have. So Pokemon in general have whatever, probably like 10 real different types. Okay, so whatever, like fire, ice, dragon, bug, grass, ground, electric, water. I don't know if I said fire. I said ground, ghost, dark, psychic, and everything else. Metal slash steel, rock, flying, poison, fighting, normal. I think everything else is fluff past Gen 5. So, the fun stuff, the maximum quality. So we can have a Pokemon and we can define an enum, a unique program-defined type that a person made, put it inside the Pokemon, because the only time we use the Pokemon type is inside Pokemon, or in the context of Pokemon. So we can access it by getting Pokemon and then the values by doing Pokemon scope resolution operator, boom, get the values. Or, for an unscoped enum, which is fine in this case, or we can do that, and then each Pokemon can have a health, can have a this, can have a that, can have an attack, can have a all these properties and behaviors. And if I want to do something to a Pokemon, maybe a Pokemon gets attacked. Maybe that's a function in a Pokemon where it gets attacked, or maybe we have a separate function where we pass in two Pokemon, and one is passed in and another is passed in, and the first attacks the second, or the second attacks the first, or two team up on a third one, whatever, something like that. That way we can actually operate on the objects and their own properties themselves, instead of having to pass all these unique, unlinked things. So if we have a player in a game, and this guy has weapons and equipment, and he needs to reload his AR-15, player owns an equipment, and the equipment is an array of the different pieces of equipment he has, and reload is a function triggered by something, and what it does is it looks into that player's equipment, checks if there's a magazine that has, or loose ammunition, loose rounds, that can be reloaded into the equipped firearm, or at least the held firearm, to reload it. So we can use the properties of the character, the equipment that he's holding, in order to perform behavior that changes the equipment, the properties of the character. So we can change them. Like a character can hold a bandage, use a function that is heal, or use bandage, or whatever, or use equipped item, and then there's unique stuff depending on the item. So we only have one use button, and we use the bandage and the properties of the bandage, its own object. It has its own how much it heals. It has its own durability. It has its own function, or at least maybe overload, something like that. I guess we would have a different overload, perhaps. So we call I'm peeling now. We call use equipped item for the character, and it uses the equipped item, and it goes into the equipped item and does whatever it is supposed to be doing. So we use the functionality of the item that's actually held by the character. So we use a property of the character in a function of the object the character is holding to then actually update the properties of the character. So there are all these distinct objects, these class objects we can have that actually own information instead of them being fully distinct. We can pass them in groups instead of having to individually pass each thing. I can have one class that has different subclasses in it that have thousands of member functions and data members inside, properties, variables inside, and I can pass that whole structure, that whole one class as a parameter, and I can do whatever the fuck I want to it in whatever it's being passed to, a member function in that case, and then I can do whatever I want instead of having to pass all the individual things in this procedural one by one boring ass method. Instead, we can create structures that hold information, and we can pass the structures to then manipulate them and use their functionality and their data members. Today we were looking at some of the differences between procedural programming and object-oriented programming in the context of having structures for animals and having a function outside of them that does something to the animal versus having an enum type of the animal and having different functions different functions that take the type of animal and return the amount of legs it has and the name that the animal has, instead of just having an object that has its own name. Because otherwise we have to call different functions on the animal. So we have this animal enum type, or this animal type enum, and we call get name and pass in animal type enum to get the name using a switch case, and then we call later on get number legs animal type enum, and it will take the animal type enum and return the number of legs. But I'm calling these different detached functions that don't intrinsically have anything to do and don't require that enum. I have to call these different functions to get values instead of those values actually just being stored in the animal we're talking about. So it's like having a picture of an animal and not being able to pull information straight from it. There's no looking at it and it has 4 legs because it has 4 legs. And it can do this because it can do that. Instead, it's like looking at an image and then having to dig into an encyclopedia to see what it can do instead. Or looking at an animal and looking into the encyclopedia. How about we just look at it at face value and use the information and behavior that it already has and owns, instead of having everything be completely separate and distinguishable. And yeah, I'm gonna leave this alone. I don't have any aloe. I wish I did. Uh-oh. Okay. All right. Let's do some quiz questions, and then tomorrow's Friday, so I can actually do some real time. I can do some hour and a half stuff again. Getting close to crunch time, so I'm about 2/3 done of my studying. So I'm hoping I can get like maybe 6 or 10 more chapters in. We can get a good ways into this, and then I'll have enough to do some real stuff. I think I already do, but it'd be nice to finish this, and let's find out what else actually is there. So we'll do classes. More about classes, arrays, different types of arrays, algorithms, dynamic allocation, deleting. Oh, so dynamic memory. More stuff about functions, how memory works, stack in the heap, where memory's going. More operator overloading, move semantics, and smart pointers. It would be nice to get at least through here. And then there's also other stuff here. But then there's inheritance and virtual functions and more templates in classes, and then exceptions, and then input and output. Like I have 14 more. I'm basically halfway through, it looks like. And I've spent 4 months getting halfway through. But I think I want to just start making stuff without knowing everything. Maybe there's probably some extra use in knowing more, but I'm getting to the point where I think I can just make some things, maybe. And maybe I have to go and find some header files and whatnot, but I want to try and make as much as I can. All right, so 128. Oops. Critically evaluate my answers. Please critically evaluate my answers. Okay, 128. Working backwards for the sake of time. 128. Object-oriented programming, OOP. Is programming that uses structures that have properties and behaviors, data, members, and functions. Allowing, or well, letting us, why is there a breakpoint here? Letting us pass these structures, classes, or these class objects as functions to read and manipulate their own properties and use their own behaviors. This contrasts from procedural programming, where variables are distinct and not intrinsically tied to each other, since they aren't owned by any class object or structure. The closest example would be a namespace. We can't pass a namespace. Well, I mean, we can't pass a namespace to a function to then access its behavior. The namespace objects and functions are in the namespace's scope, but this doesn't let us pass one object that has different properties and behavior. Well, that has unique properties and behavior. 27. Class template argument deduction, CTAD, is the process by which the compiler creates instances of a class template by giving data member, well, by matching, or by giving data members the data types of their matching arguments in object object definitions, initializations. I mean, I think probably initializations. 6. Member selection is the process by which we access data members owned by a class object, often via operator period if the class object isn't a pointer, or operator, the pointer dereference operator, if it is a pointer. 5. Oh, oops. 126. Oh! Fuck. That got me. I wasn't ready. Haven't been locked in hard enough recently. I mean, I was on vacation. I just have to get back into it. Let's see. Class template is a class that uses template types, or template parameters, template type parameters to be really to handle different data type initializers in class object definitions, i.e. we can create a point2D with ints or floats, etc., without explicitly writing multiple class template, well, class definitions. The compiler generates separate definitions like function template specializations for the object definitions that have unique combinations of argument / initializer data types. Right, let's do this. Excuse me. Okay. Let's see. Yep. Organize code around objects that, yep, exactly. You can pass class objects at, wait, oh, I meant to say two functions. Sorry, that was just spelled wrong. Oh, okay. I was trying to give the example of namespaces being the closest thing. Encapsulation, yeah, I don't know anything about these yet. Yeah, I don't know what those are yet. Yeah, I don't know what those are. Yeah, exactly, it does. I mean, that's why I was using real world examples, for example. Yep. Deduce template types from the constructor arguments. And we call those constructor arguments because when we're initializing an object, we're making a call to the constructor, so we're using arguments. Okay. Doesn't assign member types based on argument types. It deduces the template parameters for the class. Oh, I guess that's what we're saying. So we're saying, so for that definition, so it doesn't deduce the member types alone. It's deducing the type for the entire class to create a unique definition for that unique call to the constructor, which then, ow, there's a pimple over there. From a sunburn. So it creates the unique definition by matching the initializer / constructor argument, or the constructor argument data type, to the class definition from which objects are created in the member types, the member data types match. Okay. Got you. Automates the parameter specifications, so we don't need to explicitly do it. Okay, cool. Deduce the template parameters for a class from the constructor arguments. Gotcha. Class template. Okay. Blueprint for generating classes for that. Instantiations. Meaning that it just does it. Well, class template can be instantiated for any set of types. I think the point is that a specific template is instantiated from which objects are generated. So it's like a function. It's just instead of having calls to the functions, we're just creating objects. So what's happening is it's creating the set of definitions from which the objects are actually created from, or from which the objects are created. Yeah, but the whole point is that the members are owned by that guy, right? That's the whole point. Yeah. Members of a class. Members of. Meaning they're owned by it. If I am in a friend group, I am of the friend group. The friend group has me. I'm part of the friend group. Okay. Okay, well, I'll find out more later, and if I should actually change up my thoughts there. We'll see. Probably. There's always room for growth. All right, more tomorrow.